minute. Yes, 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 yes.
Uh,
Before you start, please give me a couple of seconds so that I'm just going live in the YouTube. So
yeah,
once,
yeah, sure, sure, sure. Yeah,
yes,
sure,
so
no worries.
that even the other students will take the benefit of it if the student have not logged into it, so they don't
Absolutely,
benefit of it.
absolutely.
Minute. Yes, yes. Yes, Pavan, you can go ahead.
Okay. So thank you for having me and providing me this opportunity. My name is Pavan. I pretty much grew up in Bangalore, and I'm honored and delighted to say I and Ajit were classmates during our undergrad in BE. Even though he was from information science, I was from computer science. We were pretty close friends. I should be really thankful for him to and the HOD of the department and principal of Nagarjuna College for providing me this opportunity. So my role is currently a data engineer. To give a short intro of my company, Stash is a personal finance app that simplifies investing for everyday Americans for building their wealth and have a financial goal in their lifetime. This is in short my company does. I am a part of this company for about 2 years now, where I work using big data technologies to support investment firms like for trading and other stuff. This is what my profile looks like. So let's dive in for today's trends in big data. So before going to what is big data or any of those stuff, um, mm, okay, yep. Wait, what just happened? All right. So before going to data or big data, let's just take a recap of what is data. What do we understand or what do we know about data? So data means anything which can be quantified, even your keyboard press, your discussion, your classes, anything that can be quantified. Any characters or symbols or anything like A, B, C, A to Z or 1 to 9 or 1 to million, anything where you can perform operations on it like aggregation, multiplication, addition, division, any sort of operation on it. And all this data, any data that can be transmitted or stored over the network to a different system classifies as data. So here I have just given a brief example of what sort of data we daily look at, like our transportation data, like for example, what is the bus data, where is it coming, where is it going, geographical data, cultural data, and the scientific data, which is basically DNA, medical, any sort of scientific information, financial information, statistical, that can be more like what is our GDP of India, GDP of USA, how are the stock markets doing. These things qualify as statistical data. Meteorological data is like we get these weather reports, right, on a daily level. What is the weather for today? Is there a rain and other stuff? Natural data is anything related to nature. So going one step further, let's dive into what is big data now. So here is our Jackie Chan giving us the meme saying, we all discuss about what is big data, but nobody tells us what is big data itself. So in very short, big data means any data which is huge in volume. So the huge can be quantified as anything more than a, a 500 gigabyte to more than 500 gigabyte. These things cannot be stored on, let's say, a paper or a sheet of book or any sort of data, something like that. These have to be stored electronically because in order to reduce the space occupied by this data and also for us the computation. And the other characteristics of big data is these data grow exponentially every year. So there was a recent Google study where it said the data, the searches, what they the Google search, what we performed last year was about 150 million petabytes of data, where people have searched for any sort of information across google.com or google.co.in. So this is the other characteristics of big data, where it grows exponentially every year. So there is something called as 4 V's of big data. So what is the 4 V's? One is the volume. The volume is in the size of the data, how much size is it, like petabyte, terabyte, and then it goes on further. The velocity is what is the speed in which the data is getting accumulated. Like if you look at, let's say, Google search, we just say search for something for at minute one. That is also one ping. There is another user at the same time might be searching for something else. So that is another ping for the Google. So the velocity in which the data arrives to our system is called the velocity. The variety of data, what sort of data we have, like we will have the all sorts of variety, like structured data, unstructured data, all sorts of data, that is images, documents, videos, movies. These are all classified as data, varieties of data. So the fourth one is technically not part of big data, but lately they have been considering it something called as veracity. So veracity is basically the quality of the data what we have, or what is the quality of the underlying data what we have. If the quality of the data is not right or is having some issues, then your computations, your metrics, your any sort of future goal would be hampered, because your data is skewed in this sense. So let's dive in. When we say big data, there are two sorts of big data. One is structured big data, the second one is unstructured big data. So structured data pretty much can be qualified as any data that can be arranged as rows and columns is called as structured data. So for example, you guys might have explored Oracle DBMS or MySQL DBMS in your curriculum. So the data which resides under these DBMS is classified as structured data. So the other part of unstructured data is, say you see a lot of photos in Google, you might have taken a lot of photos on your mobile. Each of these photos gets qualified as unstructured data because you cannot store them as rows and columns. Each photos are depicted as pixel, like point X and point Y, and a point Y in a coordinate of X and Y. So those cannot be structured in a DBMS level. So hence they are called as unstructured data. So this is in short what is big data. So any data which is having huge volume, grows exponentially every year, and the 4 V's. And going further, here is an example of how in US we saw some changes from, or what we saw in 2015. If you look at it, the volume of data, for example, for a Google search is about 40 zettabytes. So zettabytes is 43 trillion gigabytes. And essentially the variety of it is 150 exabytes, which is 161 billion gigabytes. And the velocity of it is from just the New York Stock Exchange, from the trade information what they collect on a daily level, is about 1 terabyte per day. So the stock market closes 10 days per year, and there are about 52 weekends. So if you do the math, that is the amount of data what we get on a daily level into 1 terabyte. And lately there has been a lot of emphasis for self-driving or autonomous cars. Like these autonomous cars uses sensors to provide the information of how the traffic is going, is there any obstacle to the car. These sensors also provide a lot of data, and these are streaming data. These comes in very streaming. These doesn't come in batches, they come in every second, every millisecond. So the velocity of the data is quite high. And if you look at the veracity or the uncertainty of data, what is the quality of the data? Here is an example where poor data quality costs US economy about $3.1 trillion a year. So if a number in the data is mismatching or having some issues, then all your say any sort of future thoughts you have done or any sort of calculations would have been in a problem because the mathematics underlying the math would have gone wrong. So this is in short what the four V's of big data look like. So going further, what domains or what are the domains where we can expect big data or where we see big data being used? One is healthcare. The second is financial institutions such as banks, stock market, other financial institutions like I would say chit fund, etc., etc. Media, like the ads, move any sort of things, insurance, internet of things. So let me give you a brief benefit of each of these domains, how they benefit from having big data. So we all know back, let's rewind us like about 7 to 8 years ago. We all used to carry, let's say we go to a doctor. Doctor used to prescribe us a medicine. We used to have some sort of document saying X medicine we have to take for 3 days continuously with whatever breaks and other stuff. And then he might have suggested us to take an X-ray. So for the second visit for the same doctor, we used to carry our X-ray, our previous prescription, all in a big cover with all documents in place every time we go to a doctor. But lately, with the help of big data, there is a new introduction called as electronic health records, where all these records have been stored digitally, and the patients and doctor can access this data over the internet at any time, at any point of time, or wherever they are situated. So that way the burden of carrying all these documents to the doctor has reduced for the patient. And also missing data or any sort of, okay, there might be cases where we might have forgotten certain documents and doctor would have said, hey, you need to come back next day and show me all those stuff. So those are not happening lately because of this electronic health record. How the second one is the cancer research. You might ask me how a cancer research would benefit from a big data. I will come back to that in the next few slides. Customer acquisition and retention. So you might have had a bank account in, let's say, ICICI Bank or an Axis Bank, right? You might have had it for about 5 6 years and you decided I have too many accounts and I have to close it. When you go to the bank, the personal manager would come to you, talk to you about why are you facing an issue, is there any way they can solve the problem. They usually try to retain the customer and also try to get new customers on their platform so that they get the revenue for it. So using big data, they can cater marketing, their focus target campaign so that they can attract new customers and also retain the existing customers. Sorry, let me just drink a sip of water. So the second one would be, or the final two would be identification of potential risks. So what are the risks? Let's say we buy an insurance, right? And from an insurance company perspective, every guy who takes an insurance might have a risk for them, because what if he takes an insurance and claims for about X amount of rupees after a month or so? So that's a potential risk for them. So identifying those potential risks using the big data and the characteristics of the customer is what insurance does in the back end in order to do their metric analysis and other stuff. So the last one on Internet of Things. So innovative products like autonomous driving, robotics, and each of these things use Internet of Things like sensors, Arduino, and other stuff in order to come up with new products and also enhance human life. So these are the big data domains and benefits. So as I said earlier, how does healthcare benefit from big data? Here is an example for medical imaging and an IBM's use case. So we all know we have been prescribed for X-ray or CT scan or MRI at some point of time, or you might have heard people saying, "Hey, I need to get a CT scan or an X-ray for my broken bone or anything." So how are these basically images generated? So you walk into a hospital and people take X-ray from X-ray machine and give you a big sheet of black printout, which pretty much resembles like this. And when you keep it in front of the light, you can see your bones, and only the radiologist can examine it and tell what is an issue with that particular report. So, and you basically take that whole printout and keep it at your home, and over the period of time, it is lost. So, how did the healthcare benefit by big data? You might ask me. So, the solution, what they did or what they are pursuing now is first thing to store these X rays, CT scan reports, and MRIs or any sort of images like even ultrasound scan as an electronic health record so that the doctor can review it at any point of time. First thing. Second thing, there have been algorithms over the period of time by using deep learning image processing like keras, pytorch, tensorflow, where they analyze these images and compute any sort of discrepancies or abnormalities found in the image. So, for example, in this particular IBM use case, you can see in the picture there are certain red blocks where they have highlighted the abnormalities found in this particular chest X-ray. So, what this does for the physician or the radiologist is to help identify abnormalities which are very hard for naked eye detection, and also support the physician's diagnosis saying this could be this disease or this could be related to this side effect. So this is one of the healthcare use case where you can see an unstructured data being used for their prediction or for their anomaly detection, or even per se for deducing any sort of disease in a patient. So the second one example what I would like to quote is how does financial institutions or banks use big data? First thing is fraud prevention. So you might have gotten a lot of OTPs for Paytm or even bank transactions lately. So the main essence of OTP is to prevent fraudulent access of your accounts and also stop suspicious activity. So how does big data fit into the role or help in fraud prevention? So when you have, let's say, a petabyte or 10 petabytes of data, all having customer transactions, customer reports, yearly reports, monthly reports, you can write up an algorithm saying what are those characteristics or features which will cater to a suspicious activity. So you might have seen cases over the newspaper saying there was $10,000, 10,000 rupees withdrawn from a customer without his approval, or a OTP did not arrive to customer's mobile, but the amount was withdrawn from his account. So how do the bank prevent these sort of transactions? So essentially the big data is where it helps. So using the underlying data in their, let's say, databases, they would do a trend analysis of each customer or a group of customers, look at their behavior, how are they performing, do they deposit every weekly, every monthly, and withdraw monthly, or they just withdraw complete amount once at a time. So they look out for features which are basically which are which are basically something abnormal for a normal customer to do. So using such sort of features, they usually detect and prevent suspicious activity. So let's say you log into your bank account, you get an OTP, you sign in through OTP, and post that you would get an email or a message from your bank saying the OTP provided by you was successfully used. Hope you have logged in. If not, please report to the nearest bank. We will try to stop the suspicious activity. So in that way, they would help in preventing the fraud activity on your account. So this is one example of how big data fits in fraud prevention process. The second one would be a 360-degree view of the customer. Say, this is not financial institutions or banks per se. This can also be used by a normal consumer product. Let's say a Britannia, for example. So Britannia, we know, makes a lot of cookies slash biscuits like Good Day, Parle-G. I might be wrong. Parle-G might be from Quality Biscuits, but my apologies. um, and there might be few more biscuits in their pipeline. So how do they cater to these, or how do they come up with this idea of, hey, let's do a pistachio good day biscuit, or let's do a almond based good day biscuit? So they look at the consumer behavior. So what is a consumer behavior in this sense? Let's say they released 100 packets of a good day biscuit in the market. Was it sold? How was it sold? How much people bought it? And what is the return on that? And they also look at the trend. If, let's say, an almond based good day biscuit is sold very high, and a lot of um, sellers come back requesting orders for it, they look at the trend. Is the trend that only on certain period the good day biscuit is sold, or is it on a yearly level? So they basically look at all this consumer behavior trend analysis, and using this data they cater marketing and advertisement based on customer behavior. So you might have seen, say, ads on Pepsi, Coca-Cola during cricket matches catering to cricket, but whereas during non-cricket days you might have seen some Coca-Cola ad which is not showing any sort of cricket in it. So this is where the big data also plays a big role, where helping the underlying company to decide what is the next prediction, or how should they predict their particular product being sold in the market, or what is their profit or loss or any sort of this one. So essentially big data is used in deriving the KPIs, the key performance indexes slash metrics for any organization, for their growth, for their goal, and for their strategy for the underlying months or for the next year. So let me jump in now to the skill set required to be a, a proficient or an intermediate level person in big data domain. So for a big data domain, you don't need a big programming language. So the underlying languages what we use in big data are C, C++, Java, Python, Golang, Scala, R. So not all these are used at once. So if you know C, and if you know how to write, let's say, a program, then pretty much that helps you in getting, so you're basically one step further when compared to others, because you know the programming language, you can write if loops, for loops, and other conditional statements. So we all know, like, the second one is structured query language, which is SQL. You guys have read about it, like MySQL, Oracle, Postgres. SQL is the underlying language for any sorts of RDBMS. Database concepts. So database concepts like windowing, aggregation, data manipulation, data extraction. These are very important concepts, because when you work in big data, you should know how to pull the data from the underlying RDBMS and use that for computing for your metrics. So the second one, the next one would be parallel computing. So this is a concept in operating systems where you can compute your logic of operations parallelly by distributing it to the underlying nodes of the system. Essentially, there are two technologies which are very hot cup of cake as of now: Spark and Hadoop MapReduce. So if I have to vote between both, Spark stands out first because Hadoop has its own issues when it comes to parallel computing. And any sort of business intelligence tool like Tableau, Power BI, Excel, in order to show or view those results in graphs, like colorful graphs across the internet, or let's say you want to view or show these results to higher management, you should know either of these tools. Excel is the most prominent one. Tableau and Power BI are, as you go on, you can learn it. Those are not complex in its operations. So, what are the roles in big data domain? As I said, I am a data engineer. There are other roles in this big data. One is a data scientist, one is data engineer, and one is data analyst. So, what does a data scientist do on a day in, day out of his particular work? So, data scientist is the one who works on data science projects from end to end. So, they basically what they do is they take large amounts of data and do a create a predictive modeling process, like using some sort of algebraic equations like logistic regression, logical regression, or clustering in order to do predictive analysis, and also present these findings using, as I said in my previous slide, like using Excel, Power BI, Tableau, etc. So the skills required for this role is mathematics, any sort of programming language, and communication. The second one would be data engineer. That is the role what I play now. So sometimes they are called as database administrators. They were called in 90s as database administrators, but they no longer are called as database administrators. They are called as data architects. So what they do is essentially we process large data sets and write architecture in a way which can be scalable, and which can also store petabytes of data and also retrieve petabytes of data in a fraction of millisecond. So essentially we take in a lot of large data sets, we clean the data sets so that it can be readable, it can be exportable, or it can be queryable. We store these data sets in a cloud or any sort of DBMS based on the requirement, so that the underlying data scientist or data analyst or higher management can view these results using Tableau, Excel, or any sort of tool. So the main skill set required is programming, as I said, C, C++, Java, anything works here. Mathematics, in order to know how parallel computing works and what data you're doing. So when you are cleaning a data set, you should know how much you are removing, how much you have removed, and what is the overall computation metrics and other stuff. And the lastly would be big data. That is, if you should know how to handle data. It's basically you shouldn't get overwhelmed with the size of the data. So for example, if I have to give my own experience at my company, daily I deal about close to 660 GB to 80 GB of data myself, where I look at certain process which is exporting data from location X to location Y, computing those data to provide some KPI metrics. So this is, you shouldn't get overwhelmed by seeing enormous amount of data. So there are tools at your access like Spark, Hadoop, which will compute 60 GB of data in, let's say, less than 5 minutes, based on the metrics what you request for it. So other useful rank-based programs which are helpful for data engineers is Python, Scala, Golang. These are also kind of good to have, but it's not important. If you learn Python, It's more versatile. You can use in data engineering, data scientist level, or even data analyst level. So it's one unified programming language. Lastly, the data analyst role. So these guys are the people who would basically take out this data, provide specific metrics across for the people across the organization. So for example, let's say there is a company X and they have about 1 terabyte of data underlying database DBMS. They need to look at their KPIs, like how is my customer performing, or how much is my AUM, assets under management. So data analyst is a guy who would basically look at the underlying RDBMS tables and comes up with a chart saying, hey, your assets under management over the period of time from Jan to May is about $2 trillion. So you basically, data analyst would sit in there, write a query using SQL, and would provide a result in some sort of bar graph or a line graph, which can be understandable by higher management. So essentially, the skills required for a data analyst role is statistics, communication, business knowledge. From a programming level, Python is good to have, as I said. Excel, Tableau, SQL are the other three prominent technologies or programs used for a data analyst role. Going further, just to give a broad idea of what are the career opportunities in big data domain uh, in Indian market as of today, and also speak about freelancing opportunities. So if you look at this, these numbers speaks by itself. So data analyst slash data engineer kind of falls in the same bracket, and data scientist is a little bit on the higher bracket because they are good at math. So if a person is good in math, he can play either of these three roles and be and grow in their career ladder. So coming further, so the question what I have been lately reading across social media like Reddit or LinkedIn, or how does freelancing fit into big data domain, or are there any freelancing opportunities for a person to be a freelancer in big data? In short, it's basically yes. The data is so much that over the period of time it has grown a lot, and companies have been trying hard to recruit a lot of engineers or data scientists to provide them solutions. However, there has been a shortage of machine learning engineers, data analysts, data scientists over the past period of time. So, if let's say a person is a freelancing data analyst, he gets paid, for example, at least for an hour from a starting level would be about, I would say, 1,000 rupees as a starting hourly rate. And it goes on as the freelancing experience goes on, the rate per hour also increases. So big data is a vast domain where people have multiple roles to play. Apart from these roles, there are also certain roles called as business intelligence developer, business intelligence analyst, machine learning engineer, AI scientist. So all of those sectors would either qualify to three of these things what I've put forth here. So it's a large spectrum where there is a large scope of growth and large aspects of learning and a good career path if any guy or any person chooses this particular career path for their next step in life. I think this is my last slide, and I would like to. The forum is open for any questions. I will try to my answer the best.
Yes, thank you so much, Pavan. Students, if you have any queries, you can unmute yourself and you can ask the questions, or you can also put your questions in the chat box.
So you feel free, guys. It's fine, and I'm not a I'm not a different person, so you can ask me anything. I'm happy to answer. I was supposed to take for about an hour, but I have concluded my presentation in less than 30 minutes.
That's fine. But still, if anybody has any questions, you can just put the questions. Okay, fine. Pavan, I do have a question.
Yeah.
One thing is, um, what are the security issues that normally we see in big data?
Security, as in you mean to say the access control issues are fraud sort of security.
Yes, yes. In terms of fraud.
So, big data can be used to manipulate anything. So, I think I was reading a report recently where they said big data was also used in US elections back in 2016 in order to change people's mindset. So how can data influence people's mindset? So this is an ongoing investigation in US as well. So how can this be catered? As you basically look at the sort of customer behavior, how are they using social media, their trends, their likes, their photographs and other stuff, and come up with a model saying, okay, these people like say some sort of food at location X, and there are other set of people at location Y who like other set of food. So how do you make sure the people on the group X dislike group Y? So you basically send out these pictures or sort of the reports saying the food in Y is not great or something like that. So you basically influence these people to think the way you want them to think about. So in a similar way, you can also influence any person who wishes to vote or do something to basically think like what you want to do. This happened back in 2016, where they say a lot of election were people were influenced by the social media and also using big data. They got a lot of information saying the candidate Y was wrong and candidate X was right. I wouldn't get into the candidate level. But so this is one way. This is actually fraud. You cannot influence a person's decision for voting. It's the decision is left to the individual voter. He or she has to decide who he likes or she likes to vote. I cannot go influence them. All I can tell them is I can do these sort of things for them once I get elected, but I cannot go behind their back and influence them using big data and social media to vote for me. So this is a big fraud issue which is still ongoing and the investigation is still ongoing. So uh, in short, having data provides us an opportunity to do anything, but there also comes the responsibility or the ethical line where you have to draw, saying this is where I start, and the one step further it basically becomes fraud or for fraudulent process. So how do we control this access? You basically monitor who is accessing and what is the level of access, and you basically compartmentalize the access for each of these groups of people and monitor day in day out. So this is one way of controlling fraud or fraudulent access of the data in deriving results. Ajit, did I answer your question?
Yes, yes, fantastic. Probably am I audible?
Yes.
Yes. Okay, fine, fine. Anybody else has any questions? Okay, fine. All right. I hope there are no more questions, Pavan. Thank you so much for delivering a wonderful presentation. So simple, and really the students have to take an advantage of all the inputs that whatever that you have given. And I again thank you so much with all your busy schedule, with the due respect to the time duration that what we have in US and India. You have taken a lot of risk. You have come up to us and delivered a wonderful presentation. Uh, so one of the faculties is asking what would be the continuation part of this webinar. Oh, we'll see, ma'am. We'll see. Kiran sir, you have anything to ask?
Yes, sir. Yes, sir.
Yes, sir.
Hello,
Please.
Pavan, sir.
Yes, you
Hi,
don't
sir.
have to call
This
me
is
sir. I'm not a sir.
yeah.
So
This is
I will
Kiran
address
from
you as sir.
Department. Okay. I don't have any question, but just I wanted to express it.
Sure.
Like before like attending this session, I was having like a little bit confusion that like because in Bangalore also we have seen that like a few MBA colleges and the B schools they
Mm-hmm.
offer like big data as a specialization. And
Mm-hmm.
I have seen few people like who did an MBA and the management background.
Mm-hmm.
After working for like 4 years, 5 years, they're doing any big data or the data science or some this kind of courses to at least to improve in their like career.
Got
And
it. Yeah.
today from this session, I got an answer that like how this big data is helping the management students to uh, like uh, predict or like a trend or like for example like financial predictions or like
Yeah.
marketing analysis. Just I
Absolutely.
got an answer and I got an insight like how this big data is works in management as well.
Oh,
I wanted to share that. That's it. Like
no,
before that, I
I'm
was having
glad.
a confusion that like why the MBA colleges offer a big data as in a specialization
Yeah.
is because like management and big data how it's. But today, like I got an answer for that.
I'm glad I was able to answer your question. So essentially, the new trend is for anything or everything, data is the thing for the solution. Even though the data looks ugly, and if you look at it from a metrics level, it will provide wonderful results. For example, in my own company, we have these KPI metrics where we visit every quarterly and we look at how the company is performing. So essentially, if a guy or a person, not a guy, sorry, if a person is working as a data analyst or any sort of data accesses, you can derive KPIs and influence, or at least go to the higher management saying, hey, there is a solution, or there is a error or something, we are looking at an abnormality. So I think the new trend over the period of time would be data centric. No more presentations or anything or everything would be just charts or just discussions of how raw data can be aggregated or quantified to derive what metrics.
Yes, sir. And this data, big data, and the data analytics and the business analytics. Is there any difference between this business analytics and the data
No,
science?
uh, it's basically the same roles. It's the same three roles which come under same umbrella of data. So the basic difference, what I would probably say is a business analytics guy would pretty much also be some sort of guy, be a liaison between a data and a requirement. Let's say for NCMS, we have to build a product, for example. Let's say
Hmm.
they want a video conferencing software like Zoom, but they don't know how to start. So the business analytical guy would basically look at how much Zoom conferences were used by NCMS as part of their webinars or any sort of usages, and how many people came in, what was the proficiency of it, were you able to integrate to YouTube or anything. So using that underlying data, the business analytics would basically derive saying, hey, I need to have a volume control, I need to have an invite button, etc., etc. So business analytical guy is basically the liaison between a data and a business requirement for a product to be built. However, a data scientist or a data analyst is the guy who would look at data and derive metrics or performance or anything. And he or she is not bound by the underlying product or the project. So let's say you put a data scientist today for NCMS to derive out what is the metrics out of this webinar. he would give you a bar chart or a line chart saying X number of people attended, X number of people dropped, or there was some mic issue or anything. Let's say you take the same data analyst and put it in, let's say, engineering in electronics department. So he would basically look at certain, let's say he goes for a lab and looks at how many ECU chips were there, how many chips died or got fried during the computation by the children. Because I was notorious during my undergrad days to basically burn every small chip which was supposed to be put in that EAD boards. So he would also look at those data and give you metrics saying there was a stock of 100,000 chips, and there are, as of now, the viable ones were about 50,000, and we need to purchase 50,000 chips in order to suffice for the next year students. So data analyst slash data scientist are not, like as I said, can work anywhere. However, business analytics depends. Certain companies, like as I said, would act as a liaison for between the software development team and the data. Um, yeah,
Thank you. Thank you.
yeah,
Any more questions? I think the students have to come up asking the questions, because you should not sit idle thinking that whether your question is right or wrong or irrelevant, whatever it is. You have to come out and take the benefit out of it.
so
Or if you are,
you
yes,
can
I
also
don't,
ask me in Kannada. Sorry to Jip to interrupt you.
no
You can
issues,
also
no issues.
ask me
We
in
can, we
Kannada.
can.
So the language is not a barrier. So I grew up in Bangalore. So as I ನಾನು ಕನ್ನಡ ಬರುತ್ತೆ ಲೈಕ್ ನಾನು 30 ವರ್ಷ ಕನ್ನಡದಲ್ಲೇ ಮಾತಾಡಿದೀನಿ. ಸೊ
Okay, I think right.
Cryptocurrencies. I just got a message from one
Yes,
of your.
please.
Uh, we are in process of dealing cryptocurrencies, but as of now, our higher management decided to push cryptocurrency trading um, down the line because our goals kind of changed, and we want to deal cryptocurrencies in the later period of time.
Okay, fine. So I don't think so. Any questions are there here, even in the YouTube? Fine. Okay, Pavan. Thank you so much. Thank you for all the answers that you have given, and really it is so relevant where everyone have to look into that and take the advantage of your presentation.
Yeah,
I request you to share this PPT so that I'll be able to give it to
yeah,
my
we would.
students as
Yeah,
well. Okay,
what I
thank you.
would probably conclude is uh, students just concentrate on your data structures, C programming or C++, whichever language you like. Concentrate on SQL because that is the bread and butter of big data engineering. If you like to pursue in the career of big data, SQL is like the most important one, where it will be used everywhere to extract data from the underlying RDBMS. With that said, I would like to thank Aruna ma'am for providing me this opportunity, and it was a pleasure talking to you guys. Thank you, everyone, and I hope you are safe during these unprecedented times. And stay safe, stay home. Thank you.
Thank you, Pavan. Fine. Okay. Shall we wind up then?
I think so.
Yeah. Yeah. Fine. Fine. Thank you.
Thank
Thank
you.
you.